questions on the homework before we get started? Questions on the homework problems? Yes. 1-3-43. Use the trigonometric identities to transform the left side of the equation to the right. So we want to show that tangent of theta times cotangent of theta is equal to 1. Well, one of our identities is that cotangent of theta is equal to 1 over tangent. And that's helpful for us here because I can replace cotangent with 1 over tangent. And tangent times 1 over tangent is tangent of theta over just 1.
So, like, is that like, do you have to show your work for the question?
Yeah.
Okay.
Yeah, so for those there that prove the right is the left or left's the right, you need to show your steps because you are going to get the same thing. So that would be the whole answer there. Yeah, 43 through 52, any of those you're going to have to show every step. Because you will get 1 in this case. Is there another one of those that y'all want to look at? Yes. Tangent times cosine equals sine. So tangent of alpha times cosine of alpha is equal to sine of alpha. So we're wanting to rewrite tangent times cotangent as sine is what we're going to end up doing. Now part of the way that we can do this is one of our properties is that tangent of alpha is equal to sine of alpha over cosine. So for our problem here, we can rewrite tangent as sine of alpha over cosine of alpha times cosine of alpha. Now we multiply by a function, cosine multiplied by a fraction is going to multiply with the top. So it's going to tell us we have sine of alpha times cosine of alpha over cosine of alpha. Part of what we're saying is we have cosine divided by cosine, which simplifies out, leaving us with. That's it, because we need it to be like the right. So we're saying sine of alpha is indeed equal to sine of alpha. That's it. Yeah, so that whole thing is technically the answer because you'll need all the steps. Because you are making it look like the right. It's just using these different formulas to replace it and get there.
Do one more.
Yeah. 49. What's our starting point for 49? Or I got the book right here. I didn't know if you had it out. 49. Secant plus tangent times secant minus tangent. I think that's equal to 1. 49, yep. So we start off with this here. Now we're wanting to make the left side be like the right. So really, when everything's said and done, we need this equal to 1, or we need to rewrite the left side to be 1. So the first thing we're going to need to do is multiply through. Secant of alpha times secant of alpha is going to be secant squared of alpha. Secant times negative tangent is negative secant of alpha tangent of alpha. Tangent times secant of alpha is going to be plus secant of alpha tangent of alpha. And lastly, tangent of alpha times negative tangent of alpha is negative tangent squared of alpha. And again, we're not going to worry about the equals 1 because we need this to become 1. Now, one of the nice things is the middle term here. Secant of alpha, tangent of alpha, minus secant of alpha, tangent of alpha. This is 0. There's been negative 1 plus 1. 0, they're the same term, but since they're opposite signs, it zeroes out. And we get this here. Questions on how we got to this point? Pythagorean identity. Yeah. Theta alpha, it's just an angle. But the general form is we have 1 plus tangent squared is equal to secant squared. So that means I can replace secant squared with what? 1 plus tangent squared. Because secant squared is equal to 1 plus tangent squared. So I can replace the secant with 1 plus tangent squared. So we have 1 plus tangent squared of alpha minus tangent squared of alpha. Well, tangent squared minus tangent squared is 0, leaving us with 1. The other way we could have the general form is that tangent squared is equal to secant minus 1, secant squared minus 1. And all that means for us here as well, instead of replacing secant, I replace tangent with secant squared of alpha minus 1. But it seems like it's different because this time the 1's negative, not positive, right? But we're subtracting it, so that negative does have to be applied to both. Our secant squared of alpha here is going to become negative secant squared of alpha. Our negative 1 becomes plus 1. Again, secant minus secant is 0, giving us different ways to get there. But we still get to the same result. Does that make sense? So it's just using these formulas to get to what we want. Questions on any of this here? Okay. Any other questions on the homework? All right. What we're looking at today are the equations of sine and cosine graphs, sine and cosine. Now to sketch the graph, if we were going to go through and sketching the full graphs, you need 5 basic key points in one period of each graph. The intercepts, where they cross the x-axis, the maximum and minimum values. So our pi over 2 pi, 3 pi over 2, and 2 pi, or to complete one full period. Now the 2 main equations we have are these here. Y equals a sine bx plus h plus k. A is our altitude. Right. Yeah. Amplitude, so A is how high up or how low it goes. Because if the amplitude is 1, the maximum minimum is going to be 1 and negative 1. That's going to make it go increase higher or lower. Our B is where we get the period. How long it takes for this function to complete one period. H is our phase shift left or right. And K is how much it's going up or down. Now we do have some of that information here. The amplitude, y equals a sine of x and y equals a cosine of x, represents half the distance between the maximum and minimum values. So if a was 2, it means the highest point is going to be 2, the lowest point is -2, which makes a distance of 4, half of that distance from top to bottom. The amplitude is equal to the absolute value of a. Period of sine and cosine functions. Let b be a positive real number. The period y equals a bx. A sine of bx and y equals a cosine of bx is given by the period equals 2 pi over b. So whatever value of b we have, we put it under 2 pi to get the period. So the period is equal to 2 pi over b. If they give us the period, we have to solve for b to know what's plugged in. Phase shift. How far to the left or to the right this is being pushed. And it does affect the b value, because our amount that we move to the left or right is c over b plus 2 pi if we're graphing it, but that's c over b value. Okay, I think it's going to be easier to see this in context of a given problem. Yes, plus h. Oh, why is that minus h? Fuck. Make sure it's not minus h. I feel like it should be. Yeah, it should be minus h. I knew I needed to fix that. Minus h. I just need to remember to fix that later. So, really we need to find A, B, H, and K. Because if we can find the values that go in these spots, we can find the rest of our information. So A, is there a number in front of sine? Well, there is. It is 1. So that tells us the amplitude is 1. The absolute value of A is our amplitude. B, so B is going to be the number in front of X. Now, it's hard to see it with this here, because X over 2 is going to be the same as 1/2 X. So our value B in this case is 1/2. H is the number being added or subtracted from the X inside the parentheses. Is there one? No, so H is 0. K is being added to the outside, which is also 0. Questions on how we found these here? Okay. So, period. We do have a set formula for the period. For sine and cosine, it's going to be 2 pi over b. 2 pi is the amount of time it takes for it to repeat one cycle. So sine and cosine, it is 2 pi. Secant, cosecant is 2 pi. Tangent and cotangent is pi. Now the value b in our case is what? 1/2. So we would just plug 1/2 in for b. telling us that the period is 2 pi over 1/2. Well, we can't leave a fraction in a fraction, so we will need to simplify, and the calculator will simplify this to 4 pi. So what that means for us is that it takes, its period is 4 pi. So for this here to make one full cycle, it's going to take it 4 pi. Questions on this here? We get about period. Amplitude. Absolute value of A is our amplitude. Well, that'd be the absolute value of what? 1. So the amplitude is 1. We'll get back to reflection. We'll talk about it here in a second. Phase shift. This is our left-right. Normally it's going to be the same because it's going to shift it this far to the right, this far to the left. But in ours, it's all based off H. So the amount that the phase shifts is 0. Because that's our H. K, up and down, is also what? 0. We can say 0 or none. There is no phase shift. There is no vertical shift. Questions on this so far? K is vertical, yep. H is going to be our phase shift, our left to right, that horizontal translation. Reflection. We will have a reflection across the x-axis or y-axis if A or B is negative. So if the number in front, the A value, if that was -1, it'd be a reflection across X. If B is negative, it's a reflection across the Y. But do either one of those spots are negative? No, so the reflection is none, there's not one. So the function they gave us is sine of x over 2, yes? Graph. Zoom 7. Okay, so it's thinking at the moment. Yeah, I might have locked it up. Okay. Yep. Okay, I'm going to have to shut it down and bring it up later. But we are able to graph these here. The graphing calculator has decided to quit. But questions on how we found this information? This next one here, y equals -3 cosine of 2 pi x plus 4 pi. And again, we're going to need to find the same values, a, b, h, k. If we do have something being added or subtracted inside the parentheses, we're going to have to change it just a bit. Because this shift left and right and the period are affecting each other. So one thing we have to do before we can really see what the phase shift is, our left and right movement, we do have to factor whatever the period that value b is out of both terms. For us, for the first one with x, it's just going to become x. We're just going to divide 2 pi x by 2 pi, whatever number's in front of it. The other one, the 4 pi, whatever is there, we're going to divide it by 2 pi. Well, 4 pi divided by 2 pi is just 2. Because that period is going to affect the phase shift. That's why when they talk about the phase shift, we have this C over B. They use C instead of H. But it gets us to the same spot. Okay. Minus. So, A is what? -3. B is 2 pi. Why am I doing C? I keep doing C. H is 2. K is 0. Really, we would say -2, but H, 2, -2. Okay. Questions on A, B, H, K? Well, out of all of them, there's one that's really nice, and it's vertical shift. Because that value is 0. So the vertical shift is none or 0, whichever way we want to do that there. Phase shift, left, right. 2 to the left, 2 left, left 2. Is A or B negative? A is negative, so it's reflection across the x-axis. Amplitude, absolute value of A. Well, the absolute value of -3 is 3. Amplitude is 3. Now, the period we actually have to calculate. Period is equal to 2 pi over, so 2 pi over 2 pi, yes? What is 2 pi divided by 2 pi? So the period for this one is 1. Okay. Yeah. So, cosine of x graph. So there's our normal cosine function. Now the one that we have is -3 cosine of 2 pi x plus 4 pi. Zoom. Number 7 is trig. So it'll get it actually between, so our numbers aren't, on the x values are going to be pi over 2 pi, 3 pi over 2, 2 pi. So they get a better trig standard. Let's see if it'll do this here. Second table. Table, let's do pi divided by 2. And again, they're giving us in radians, so it doesn't help us a whole lot. But every 1 unit, it should be repeating. So it'll be 3 or -3. Well, actually, for 1, it should get back to 2 pi. But we can see how it's repeating a lot faster than the other, because 2 pi is 6.28. So what we're saying is that this new one should go through almost 6 full cycles, 6 full periods before the other one does 1. So that's why it's repeating faster. and it is shifted a little bit to the left. Any questions on how we got this here? We feel all right with this here? All right, we're ready for the next one. Most of the rest of these will all end up being dealing with sine, but sine and cosine will work almost the exact same. Now, what's our value of A for this here? 2/3. What's our value of B? H and K, 0 and 0. Phase shift is none. Vertical shift is none. Reflection, well, the number in front of X is not negative, and the 2/3 is not negative, so that's also none. Amplitude, well, that's the absolute value of A, and the absolute value of A, or absolute value of 2/3 is 2/3. Period is going to be 2 pi over B. Well, that's just 2 pi over 1, which is 2 pi. Questions over this here? Now, the amplitude being 2/3 means that the maximum and minimum value are going to be 2/3 of what they should be. Well, that's 2/3 of 1 or negative 1. Which means for us, so we're talking about sine of X. Here, instead of it going to 1 and negative 1, we should go to 2/3 and negative 2/3. 2/3 sine of X. And that's exactly what it did. It has the same period. It repeats in the same cycle. It's just 2/3 of the maximum and minimum values. And that's it. Questions over this here? Let's look at the next one. Now, we don't have to worry about factoring the pi out because we don't have anything else being added to it. We don't have parentheses pi x plus 4 or something like that there affecting that left-right shift. But that also means H and K are both, again, 0. Our B value is pi, and A is 4. Let's fill some of this in. Vertical shift would be none. Phase shift, none. Reflection, none. Amplitude, 4. Period. Period would be 2 pi over B, which is, so the period would be 2. So every 2 units along the X, this should repeat itself. So that means compared to our normal sine function, it should repeat almost 3 times. Sine of X, I think it was pi X. As we can see here, it does repeat itself a lot faster. questions on this here? Okay. Now we do have -4, yes? Are there parentheses written? So would the -4 be h or k? It would be k. Because unless parentheses are stated or written, the -4 is outside. Really, what this is telling us is that the 1/2 x is inside parentheses and the -4 is outside. Because unless they specifically write parentheses, including the -4, that is outside parentheses. Which means h is 0. The value b in our case is 1/2, and the value of a is 1. So amplitude, 1. Reflection is none. Phase shift left or right is none. But our vertical shift would be down 4. Since it's negative, it would be down. Period. 2 pi over b, so 2 pi over 1/2. Which I think we've had already, yes? Which would be 4 pi. Questions on this here? So, I'll write the general form y equals a parentheses. Try again. Y equals a sine of bx minus h plus k. Now looking at this here, a is what? 1. B is 1. H is almost. It'd be positive because the general form has a negative. Because it's going to come out with that sign flip. And k is 0. Because it should be bx minus h. So here, since it is minus pi over 4, it's actually h's value is positive. Which tells us for our phase shift, we're going to go right a distance of pi over 4. Vertical shift is none. Reflection is also none. Amplitude would be 1. Period is, it'd be 2 pi over b, but b is just 2 pi. Now, if we look at the graph, we said it shifted pi over 4 units to the right. So it is shifting right, because the graph in red would be the new one. And we can see that it is shifted to the right that far for each and every single one. A, B, H, K. A in our case is 4. B is, H is 3 pi over 2. Since it's minus it inside the parentheses, it would come out as plus, positive. And K is 0. Vertical shift, none, since K is 0. Phase shift, right, 3 pi over 2. Now, we didn't factor anything out because the value B is 1. Reflection is none. If you get a value B other than 1, we have to factor it out of our left, right, our H. Amplitude, 4. Absolute value of A, absolute value of 4 is 4. Period is 2 pi over B, but for us that would be 2 pi. Questions on this here? Well, again, B is 1, so I don't have to worry about that value affecting the H, having to factor it out. Well, let's go with the rest of them. A would be H, almost. It would be negative pi, because since it's plus inside, it's going to come out as minus. K is negative 2. So since we do have a K value, we do have a vertical shift of down 2. Now this time, since H is negative, we're going left pi. Reflection, none. Amplitude, absolute value of A is 3. In periods, 2 pi over B are just 2 pi. 3 sine of x plus pi minus 2. 3 sine of x plus pi. Was it minus 2? Well, you can see that there. I'm going to remove the minus 2, so we're not going to see the down 2, but it is moving everything a distance of pi units to the left. Let's just look at that there and how those two. Now this is going to be nice where it's actually having this pi over 2. Oh, and past 0. Because everything's going to be shifted over just a little bit. It'd be nice if okay. Table set. Table start at 0. But it does shift because these high points, instead of being up here, are now over here. Because it shifts it half of that to the left. Incidentally, it could have shifted it off just so to the right, because that amount of pi does do that. But that's just because of pi. But that's all we're going to do today.